We're very happy to be here. We will all three be doing different things, and we will try to do a video to show you what this exercise is about. We're going to be making a helicopter. We have to be very polite with each other, and we have to take turns. You remember, I'm Colleen. Hannah's going to talk a minute, and Lynn's going to talk a minute, and then Hannah will start your lesson.
Hi, everybody. It's nice to see you. I am going to be explaining the lesson to you. I'm going to be explaining it step by step so you can listen to me for the directions on what to do as you go along. As Colleen mentioned, she's going to be holding up the helicopter along the way, so you can look to her and Lynn for help along the way. And if you have any questions at any point, you can ask Mr. Crawford or you can just say them out loud and I can do my best to try to answer them. Lynn?
Hi, everybody. Good to see you again. I'm actually going to make a helicopter right along with you. So when Hannah gives you the directions, if they don't really quite make sense, you look up at the screen and you'll see me doing the same thing that you're supposed to be doing.
Today, before we get started with our cutting and folding, we're going to show you a short little video that NASA came out with that kind of shows you a little bit their design process and their thought process, because just like you, they had to spend a lot of time creating and trying to figure out, how they wanted everything to work.
The other day, they just landed on Mars, a new probe it's like a Martian rover. So it's almost like it's a four-wheel drive truck or a remote control car that they could drive around on Mars. Okay. So it takes about 11 minutes, roughly 10, somewhere between 10 and 15 minutes for them to send a signal from the Earth to Mars to tell the rover what to do. Then it takes 10 or 15 minutes for the video to come back to Earth. So it takes about 30 minutes because Mars is so far away in order for them to get to that point. So part of this rover is it has a helicopter in it. It's just a little helicopter. So it's almost kind of like a good way to think of it. Comparison on Earth would be it's a helicopter, but it's kind of like a drone too. Have you ever seen drones that have taken pictures? So it's kind of similar to that.
Today we're going to make a paper Mars helicopter. We have satellites in orbit around Mars that take global pictures, and we have a rover on the surface that takes up-close pictures. But there are some places on Mars that a rover just can't go. They're too rocky or too steep of a cliff. So the next Mars rover, Perseverance, is going to take a helicopter attached to its belly to the surface. When it gets there, it's going to deploy the helicopter. The helicopter will fly around for a series of test flights. If we're lucky, we might get some pictures of surfaces that we can't see with the rover. Now, these test flights are going to be really short, no more than about 90 seconds. And if they're successful, the helicopter will come back, land on the surface near the rover, convey the images to the rover, and then the rover will convey those to Earth where we can see them. The hard part about flying on Mars is the Martian atmosphere is so thin. It's only about 1% the thickness of Earth's atmosphere. What that means is if we were standing on the surface of Mars and there were a 100-mile-an-hour wind, it would barely disturb our hair. So it makes it hard for an aircraft to fly in very little air because aircraft needs to be able to generate enough lift. Lift is the force that is applied to the rotors by the air that lifts the whole aircraft off the surface. The Mars helicopter has angled blades just like helicopters on Earth, so that when they rotate, they run into the air and cause a high pressure that will push those blades and the helicopter up into the air. Now, the Mars helicopter is very lightweight. It's only about 1.8 kilograms, and it has really big blades. They're about 1.2 meters wide, which is about 4 feet or so. And they rotate 10 times faster than helicopter blades do on Earth. Now, engineers had to do a lot of testing. They had to figure out what kind of a helicopter blade is going to help that helicopter get off of the planet. We have a chamber at JPL where we could pump out a lot of the air so we could test it in an atmosphere a lot like Mars. And we could also offset the gravity using a tether. Now it's time for you to make a Mars helicopter.
All right. And I don't know if the video we watched actually mentioned this, but this is the first helicopter ever on the surface of Mars. They've sent rovers before, but they have never sent a helicopter. So this is very exciting. And the helicopter's name is Ingenuity. And they actually had a contest and a student was able to pick out that name for NASA. Is everybody ready to get started? Can we get thumbs up? All right, can everybody hold up one sheet of paper and their pair of scissors? Awesome. What we're going to do is, you see on each paper, there are 2 helicopters. We're only going to cut out one to start out with, okay? And what you're going to do is you're going to cut along the dotted lines. Don't cut along the solid lines, only cut along the dotted lines.
All of them?
All of them. We know it may not look like a helicopter just yet, but it will. Trust us.
We only have to do one side, correct?
Correct. And just to give you a little background as you're cutting, the purpose of this Mars mission is to try to collect data and take pictures and see if they can find evidence of life in the past. They know that this particular spot on Mars where they landed it is a crater, and it used to be filled with water. And they want to see if maybe a long time ago, when there was water, there was life. So they're going to collect rock samples, and the helicopter is going to take pictures, and they're going to send all that information back, as Mr. Crawford said in the beginning, back to Earth.
All right, so I think everybody's got it to this point. They've got it cut out. They've got this part of it, and they've got that part of it right there. So those are folded. You can see that, okay?
Perfect. Is everybody ready to move on to folding? All right, so you cut along the dotted lines, and then the solid lines are where you're going to make your folds. You are only going to fold along the solid lines, and we're going to start with X and Y. You're going to fold X and Y inward so that the body of the helicopter ends up looking skinny and kind of like a T. And you can look to Mrs. Haskell and Mrs. Alley for help as they're doing it too.
Mine is like this.
All right, looks good. Make sure you're folding on the line.
Okay, so it shows Z at the bottom.
Awesome, good job.
It only shows Z? Yeah, it shows Z on the bottom right there in the square.
Good job.
I can't.
Perfect.
Did I do it right?
Mine doesn't only show Z.
Yeah.
All right.
All right. When everybody is done folding X and Y, they're going to take Z at the bottom and they're going to fold it up. And folding Z up is going to help your helicopter be more stable when it flies.
Like this.
Yep, fold it up. Yep, just like that.
Like, is it like this? Yeah, it's like this one. Z has to show. Okay.
Awesome helping each other.
Like, and then you take the Z on the bottom. Like this. No. Like on the back of it. Like fold it on the back. And then this. What?
Okay,
We're not talking about TikTok.
okay. All right.
Is everyone done folding Z?
All right. Okay.
Thumbs up if they've got Z.
Like this, they see.
All you have to do, so just take it like this and fold it So your Z would have been right here.
Like this, but
Okay.
not
Let's
on
do
the
it
X
this way.
side, but
Fold
on the
that.
left side.
So then fold it like that, like
And just
that.
hold it up.
And then see that part is where your Z would
Yours
be?
still shows
Fold it
that.
up, like that.
Yes,
All right. Point is, it still should work. Okay.
They look like people. Yeah,
Alright.
it looks like these are the legs, this is the body, and there's the tiny head.
All right, just one more step. Now we're going to fold A and B. And listen up. You're going to fold A towards you and B away from you. So you're going to fold them in two different directions along the solid line.
I did it. It's like this. Is it like this? No, like this. What?
Make sure you fold on the solid line.
Really?
Oh, don't drop them quite yet. Wait a minute.
All right, sit back down.
How do you do
guys.
that, Mommy? I need your help.
Time out. We're gonna get somebody caught up.
It actually does work.
It looks like some of them aren't folding on the solid lines.
Yeah.
I think it's going to work better if they fold on the solid lines.
So see the solid line right there?
So it makes the
Quite yet.
blades look actually crooked when you do that, but they're supposed to.
Everybody sit
Like this?
down. Okay, Nancy, sit down, Lacey, sit down, Harmony, sit down.
Whoa!
Okay.
Word.
See the solid line right there?
And A and B are going to be what they call the rotors. Those are the blades of the helicopter.
I think they figured it out.
Well, but they're tossing, so they're not, they get a good rotation.
I figured out something. If you fold back down the Z, it will land
Okay,
once you drop it.
right there.
Observation.
Anna's gonna show you some hints about flying your helicopter that are very important. And I've seen some of you doing it and you're not getting the rotation. So you watch what Hannah will tell you how to do it so you get a good spin.
All right. So there are two ways to hold your helicopter. You can, one, hold it by the body, just like I am. Or two, you can hold it by one of the blades. It doesn't matter either way. What you want to do is you want to hold it as high as you can in the air. You can raise it above your head. And what you want to do, you're not going to toss it. You're not going to toss it up or toss it forward. All you're going to do is get it as high as you can. And on the count of three, we're just going to let go. Okay? 1, 2, 3.
Whoa! I need a chair.
If
Let
someone
me do this.
carefully maybe stand up on a chair, if you're careful, you can do that too. Yep, as high as you can. Don't throw it, just drop it and watch what happens.
That's cool.
You guys can do it a couple times if you want, and then we can come back together and we can talk about what we've seen.
I want to make another one.
Well, that's why you have a bunch of different sheets of paper. Does anybody want to raise their hand and share with us what they noticed, what their helicopter looked like when it was flying? Is there any way that you can describe it?
You got Molly right over here. Let's see what Molly says.
I saw that it looks a lot like the helicopter that they sent on to Mars.
That's good.
It isn't what it looked like, but I liked it when it spun. It kind of looked like somebody cut up an umbrella.
Very good.
Yeah.
Observation. Did it look like what you thought it was going to look like, or did it look different?
Different. I made another one. Ooh, I'm gonna make them race. They're racing.
All right.
One race.
Yeah. All right, Harm, then we
Raise your hand if you think your helicopter fell quickly, fell fast?
It's all.
Guys, we got a whole bunch of them to say.
Raise your hand if you think your helicopter fell slow. Is there anybody? Oh, yeah, a couple.
Yeah,
hands.
sometimes, yeah.
Maybe faster somehow.
What do you think would happen if we made the blades shorter? Do you think it would fall faster or slower if the blades were short?
Faster!
Yeah.
So this actually has 2 papers glued to it, and I'm gonna try it. It spins way better with 2 papers glued to it. Just 2 layers.
Tip it like that, Nancy, so we can look at it. Point where you, oh, you put some on the end? Is that what you did? You put some on?
Now, I put 2 layers. 2 layers of paper.
Oh, you made 2 helicopters and put them together?
2 layers of paper. I have something to say. I cut my blade shorter on one of mine, and this is the one that I cut my blade shorter. And this is the one that I didn't cut them shorter. The shorter ones are faster. Yeah, look.
For some of you that made your helicopters shorter, you noticed that it fell faster. Does anybody have any ideas as to why maybe it fell faster with shorter blades?
I think it fell faster because there's less weight on it.
That's a good idea.
I think it went faster because the sides were shorter and because it didn't have that much paper on it.
All right, good observation.
I folded these up a little bit and it felt a lot better. If you fold them up just a little bit, it falls a lot better. Oh my God, Mommy. That's so true.
And if I can ask, why did you decide to fold them differently?
Because this one was just folded wrong and I thought, and then I did it and then I realized the things were folded up more and it felt a lot better. So I tried this one.
Put them together, Molly. Let them go together. Put them right up and let them go at the same time.
When this one goes,
See,
this one goes a lot better. Yeah, this one goes way better. And then you can fold them down. And it spins on the ground. It spins on the ground. It spins on the ground.
What I've been noticing is that a lot of you guys have been experimenting. You took the helicopter that we taught you how to build, and then you went off on your own and you modified it. You did different things. You might have folded the blades differently. You might have cut the blades different lengths. You might have changed the way that you were holding them when you were falling. And that is a really important part of the scientific process, because what you were doing is you were trying to figure out how to take the original design and make it so that it works better, which is exactly what real scientists do all the time.
Who can tell me what Hannah just said? Harmony just had a good thing. What did Hannah just say? Something about science. What are we doing? Molly, what did she just say?
Modifying it is part of the
Scientific method.
process.
Right, scientific process. Good.
And if you make the bottom like straight, it falls way better. Look, and you can do it upside down. Oh my God, Bentley!
Yeah.
You can do it upside
Do
down.
the blades rotate if you do it upside down?
Not as much. Mine flips over. It's way better when you do this. I have something to say, and this is what I have to say, is if I cut these really short and they don't go as good. They look really fast, but it doesn't look cool.
Good observation.
This is so cool. I'm bringing this home. Oh, do we get to color them? We should have colored them before we cut them out.
Yeah, if you want to color the other ones you make later, you can.
Yeah, I'm gonna put this in my room.
All of the helicopters are at the airport. The FAA, Federal Aviation Administration, is checking them out.
What? What
does
that even mean?
Well, you'll find out in a few years.
Do you kiddos know when the actual rover and helicopter landed on Mars? During your vacation week last week. Do
Right.
you know when it left Earth?
No.
Last summer.
What? That's
Yes. So it took it all the time you've been at school, plus some of your summer to get from Earth to Mars.
Wow, that is awesome.
Yeah, so February 18th, that was last Thursday. So
Yep.
let's, guys, watch. Yeah, so let's watch the rover land. And I actually watched this on TV.
Perseverance has now slowed to subsonic speeds and the heat shield has been separated. Skycam maneuver has started. About 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
No, I don't.
Oh, come on, it's even nuclear powered too.
Okay, then I'll have it. I'll watch that.
The coolest part, I think, was that right before the rover reached the atmosphere of Mars, scientists, they took a step back. They let the rover land itself, which is pretty cool. So all throughout its descent from the Martian atmosphere down to the surface and trying to find a good place to land, the rover did that all by itself, which is pretty cool.
I wanted to know if they saw people cheering in that last video.
That's why I said they went crazy.
One of
Who do
the
you,
people was a scientist from Maine.
What?
So it just shows you that if you have a science mind, there are many things you can do. You can work with helicopters on Mars. You could work with propellers underwater in marine science, which would be something probably DEI scientists would do. But there's always something a scientist can do to help out our world. And a Maine person was right there when rover landed.
what I liked about the video was when the scientists and the engineers cheered, because they spent years, some of them have spent years trying to figure out how to make this work. And so they were very, very excited. And there were actually a few minutes when they lost, which they knew would happen. They lose contact with the rover. There's like 7 minutes when it before it lands that they lose contact. So they're very excited when they get that, when they reestablish that that contact. But they were excited about their landing, just like you guys were excited the first time you dropped your helicopter. In my house, where I am now, to get to our upstairs, we have a lot of stairs. I think there's 18 or 19 stairs to get upstairs. So, and then when I get upstairs, which is where I am now, I'm in a room where there's a little railing, and you can look out over the railing and look downstairs into the dining room, and it's about 15 feet. So I drop my helicopter every time I go downstairs. I leave my helicopter when I'm upstairs right by the steps. I drop it down every time. And I actually have, I don't have it with me right now, but I have this helicopter, and I have a second helicopter with blades that are only half as long, and I drop them at the same time so I can compare them together like some of you did. Now, what do you think happens when I drop my helicopter with long blades and my helicopter with short blades at the same time?
So
The
let's,
long ones went slower and the short ones went faster.
okay, go. Nancy's got a good theory. Go ahead.
The
Nancy.
long ones went slower and the short ones went faster.
That's absolutely correct. So
Alright.
then why would they put such long blades on the real helicopter?
So the one that they. what- All right, go ahead, Nancy.
Because they don't want it to land faster than crash.
Excellent, excellent. One of the times that I dropped my helicopters at the same time, I try to, I hold them apart, but one time I evidently maybe didn't hold them apart or dropped it a little different, and they actually bumped into each other on the way down. And that really was bad for the one with the long blades. It made it go all crazy the rest of the way down. The one with the shorter blades, however, was able kind of recover and do a nice spin the rest of the way down. I thought that was interesting.
Do we want to try one more quick activity with our helicopters? Up until this point, you've been dropping them and just letting them land wherever they fall. But what happened with the real helicopter is scientists picked a specific spot on Mars called Jezero Crater, and they, out of the entire surface of the planet, they wanted the helicopter to land there. It was their target. So I wonder if you guys can try to fly your helicopters so that they hit a certain spot every time. So let's try flying them again, but this time try to hold it in a way, try to get it to land on your feet. And that will be your target.
Get it
Does that make
to
sense?
All right.
Mine just missed it. My helicopter is the same. How many has mine landed on my feet? Oh, that makes it go slower.
Yeah.
Look. I have something to say. I just made all my helicopters, but I designed them all in a different way. This one has like spiky things, and this one has a slant inside of it. And then this one, it has a tiny bit cut off of it. This one has a lot cut off of it. And that.
Do you know that's what engineers do? They try different things to see if they can get there, whatever they're trying to invent, to do something different
Fly 'em,
or to make it better.
fly them.
We're gonna drop them all at the same time.
Okay.
2, 1, go. This one won.
Which one was it?
Which one?
It was the shortest one.
Show us the blade.
This one. This one won.
Did it
I'm
still
gonna drop them all at separate times.
Now, we want to know which one goes
Stop, guys,
lowest,
here.
because we don't want to smash up the camera on that helicopter. So drop them again and tell us which one goes the slowest.
I'm gonna drop them. Here, I'll drop it from above the camera so you can see it fall down. Here. Okay, take this one and this one.
Guys, move that,
3,
what, excuse me.
2,
what's-
1. This one went slowest. The one with the medium blades. This one was like the second slowest. This one was slowest with the medium blades, and this one, the normal one, was like the second fastest.
Harmony.
Yeah.
If you had something valuable, like a camera, a billion-dollar camera to take pictures on Mars, which helicopter would you choose to be carrying that camera? And
Probably the slowest one. Let me see. I want to drop all of them at separate times. My one with the holes in it first. My one with the spikes on it. My short one and my medium. I would have. Who wants to see mine? My one with my spikes on it, because that one doesn't go too fast. He doesn't go too slow.
Very good.
Look at look.
We have probably got to wrap up.
This is what my one that I would go to Mars with my camera with.
All right, everybody
is
back to
mine
your
too.
seats, please.
Oh, wow, she's colored hers.
Back to your
It's I
seats,
mixed
guys.
pink and blue. And I made this blade to try.
Well, okay, ladies and gentlemen.
I made one
let's
that is round on
listen,
the side.
okay?
We've had a great time with you.
We get a thumbs up if you guys enjoyed doing this activity.
Yeah, gotta get into the camera, thumbs up if you enjoyed it.
Love to see all those thumbs.